Hello viewers, welcome once again to Esomnofu online math class. Today we are going to continue with the application of differentiation. If it is your first time of viewing, kindly subscribe to my channel and don't forget to press the bell notification icon. This will make you to be notified whenever I upload a new video. Okay, now this application of differentiation is known as rate of change. Normally, a change in one quantity must cause a corresponding change in another quantity. Just like when the price of fuel is increased, you will see that it will cause a corresponding increase to various prices of different items. For instance, if you have 10 naira, you can buy, let's say, a sachet of water. If the amount of money you have increases to, let's say, 20 naira, you will see that it can cause an increase to the number of to the quantity of sachet waters you can buy. So an increase can bring up an increase or a decrease depending, because if I increase my speed, it will decrease the time I will reach to my destination. So it does not necessarily mean that an increase must always cause an increase. So an increase, which is a change, can cause a change, whether a positive change or a negative change. And that is what we mean by rate of change. So you can see that the radius of a circle is one of the parameters used in getting the area and even the circumference. So now, whenever the radius is increasing, it must also cause a corresponding change or increase to the area, because we are told here that the radius of a circle is increasing at the rate of 0.01 centimeter per second. Find the rate at which the area is increasing when the radius of the circle is 5 cm. Provided that the radius is increasing, automatically the area must also increase. And this is one of the important areas differentiation is applied. So now, the radius of a circle is increasing at the rate of this, which means the r over the t. This means that the radius is increasing with time. The rate of change of radius with respect to time will give us 0.01 centimeter per second. Find the rate at which the area is increasing. So you want to get the rate at which the area, which is the A over the T. The area also increases with time. Hence, the A over the T, we don't know. That is what they want us to get. Okay. We are also told that the radius of the circle is 5 cm. Now, what is the formula for the area of a circle? The area of a circle, area A, equals pi r squared. So the rate at which the area increases with respect to the radius will now be dA over dr. That is the rate of change of the area with respect to the radius. So when I differentiate this from the formula of differentiation, you will see that the power will come to the back. Remember, this pi is a quantity, so you don't touch it when you are differentiating. So 2 coming to the back, we shall have that the ADR is just 2 pi r. You can say 2 minus 1, and 2 minus 1 is just 1, which is nothing. So this is our dA over dr. From chain rule, we shall know that dA dt, which we are looking for, should be dA dr times dr dt. You can see that when dr cancels the r, you shall still get dA dt, which is what we have at the left hand side here. Hence, my dA dt will give me dA dr, which is 2 pi r times dr dt. My dr dt is 0.01, so I'll write 0.01. But what is r? R is the radius of the circle, and the radius of the circle is just 5. So dA dt will give me 2 pi times 5 times 0.01. Now 2 times 5 is 10, and 10 times 0.01 will give me 0.1 pi centimeter squared per second. Remember, if you like, you can use the value of pi as 22 over 7 and multiply it with 0.1 and you get your answer. If you like, you can keep it in terms of pi. Remember, the unit is centimeter squared per second because area is in square units. Okay, so now the rate at which the area is changing is 0.1 centimeter squared per second. So you can now see that when you change the radius of the circle at 0.01 every second, the area will change at 0.1 pi centimeter squared at the same time. So you see that when radius changes, it will cause a greater change in the area. So this is one of the applications of differentiation. So let us take more questions in this topic for proper mastery. The second question says, find the rate at which the volume of a spherical balloon is increasing if the surface area is increasing at the rate of 5 centimeters squared per second when the radius of the spherical balloon is 4 cm. Find the rate at which the volume of a spherical balloon is increasing. So rate of increase of the volume is the V over the T, because it will increase with time and we don't know, so question mark. If the surface area is increasing at the rate of 5 cm squared per second, so the A over the T, the rate the surface area is increasing is 5 centimeters squared per second when the radius of the spherical balloon is 4 cm. So our radius is 4 cm. Now we talked about the volume, and you should know that the volume of a sphere is 4 over 3 pi r cubed. Hence, the rate the volume is increasing with respect to the radius will now be dv over dr, which will give us 4 over 3 times, the 3 comes to the back, we have 3 pi r 3 minus 1. That's the way to differentiate. The 3 comes to the back, multiplying pi r, the power minus 1. So 3 will cancel 3, which I have that our dv over dr will give us 4 pi r squared, because 3 has cancelled 3, we are left with 4 pi r, and 3 minus 1 will give us 2. This is the rate the volume is increasing with respect to the radius. Also, we had about the surface area here, and you know that the area of a sphere is 4 pi r squared. This is the formula for getting the area of a sphere. So the rate the area is increasing with respect to radius will be dA over dr, which is 4 is here, multiplying 2 pi r 2 minus 1. So dA over dr will give us 8 pi r, because 2 minus 1 is 1, no need of writing 1 here. So this is dV dr, and this is the A dr. What are we looking for? dV dt. So dV over dt is the same thing as dV over dr times dr over dt from chain rule. This is just the formula. dV dt is dV dr times dr over dt, such that dr can cancel dr. We are left with dV over dt, as you can see here. But we have our dV dr as 4 pi r squared, but we don't know dr over dt, so we need to get dr over dt. So let's wipe off here and get dr dt. So we can only get dr dt from dA over dt, the rate at which the area changes with time. So the A dt will give me the A over dr times dA over dr times dr over dt. Okay, because dr will cancel dr, giving me dA over dt. Okay, so now to get the r over dt, it means dividing this by this. Hence, the r over dt, which I'm looking for, will be the A over dt times, or rather divided by the A over dr. So the r over dt will give me the same thing as the A over dt times, I'll turn upside down, dr over dA. Okay, so I'll turn this upside down. So what is the A over dt? The A dt is the rate at which the area is changing with time. So this is the rate, which is 5 centimeters squared. So I'll call it 5 times dr over the A. But here I am having the A over the R and not the R over the A. Therefore, what I'm going to put here is that instead of writing 8 pi R, I will turn it upside down and write 1 over 8 pi R. So it will give me 1 over 8 pi R. When I multiply this, will give me 5 over 8 pi R. This is my dr dt. So from the formula, I can now get my dV dt, because dV dt means dV dr. dV dr is the rate the volume changes with respect to time. So let's continue from here. dV dt, which I'm looking for, will just be dV dr. Volume, remember initially we said that the volume is 4 over 3 pi r cubed, and after differentiating it, we found out that dV over the r gave us 4 pi r squared. That is our dV dr, though I've wiped it off. So it's 4 pi r squared. So seeing dV dr, I'll write 4 pi r squared times the r dt. My dr dt is 5 over 8 pi r. So I'll have 5 over 8 pi r. 5 over 8 pi r. So now, pi will cancel pi. R will cancel r. I'm having just r here. Okay. 4 will cancel this. We have 2. So I'm having I'll have my dV dt as 5r all over 2. But what is the value of r? I am told that my r radius is 4 cm. So I'll just plug in 4 for r here. I shall have 5 times 4. 5 times 4 all over 2. So my dV over dt will give me 5 times 4 is 20 all over 2, and 20 over 2 will give me 10 centimeter cube per second, because volume is in cube. So the rate the volume is increasing with respect to time will give us 10 centimeter cube per second. If you've enjoyed what you've watched, kindly subscribe to my channel to be notified whenever I upload a new video. Thank you.